Find the de Broglie wavelengths.
Yes, sir.
Of.
Sir.
Find the de Broglie wavelengths of.
Find the de Broglie wavelength
Of a 46 grams golf ball.
6 grams golf ball. Yes, sir. Yes, sir. Written, sir.
Moving with a velocity of.
Moving velocity of
30 meters second inverse.
3 meters second inverse.
30.
Yes, sir.
And
My voice is breaking, sir.
I'm using headphones, maybe that is the reason.
Yes, sir.
Okay. So 46 grams golf ball with a velocity of 30 meters second inverse.
Yes, sir.
Second one, electron.
Yes, sir.
What is the mass? 9 into 10 to the power of minus 31 kilograms. Moving with a velocity of.
Yes, sir.
10 to the power of 7 meters second inverse.
Moving with the velocity of
10 to the power of 7 meters second inverse. They can ask given the ratio also.
Yes, sir.
So you are asked to find the wavelengths. Lambda 1 is H. Direct substitution. 6.
H by mv, sir.
No need of, you should not write formula now. In the space for rough work, you must substitute the values.
Yes,
So,
6.6 into 10 to the power of minus 34 by 46 into 10 to the power of 3, 46 into 10 to the power of 3
minus 3
grams to kilograms. Yes, sir. Minus
So be careful. Multiplied by 30.
Yes, sir.
Correct?
Yes, sir.
What? Tell me the answer fast. 10 seconds.
Yes, sir. 60.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over.
Sir, multiplying.
It should be 4.8. 4.8 into 10 to the power of minus 34 meters should be the answer. Simple, man.
Yes, sir.
6.6 by 3 into 46. 138. Correct?
Yes, sir.
Yeah, you make it this 10 to the power of minus 3, you take it to that side. So it is 6,600 by 138. So nearly you will be getting 4.8 into 10 to the power of minus 34.
Yes,
yeah. This is the logic of simplification. Even simplification should be done as fast as possible. With accuracy, of course. For electron.
Yes.
Yeah. 6.6
Yes, sir.
into 10 to the power of minus 34 by 9 into 10 to the power of minus 31 into 10 to the power of 7. Correct?
Yes, sir. 34, 7.
So this is 10 to the power of minus 10. Correct?
Yes, sir.
And 6.6 by 66 by 9 into 10 to the power of minus 10. So around 9 sevens. 63, 30, 9 threes, 7.3 angstrom units. Correct?
Yes, sir.
.3. I think it should be 10 to the power of minus 11. Nah?
Yes, sir. That one I told you.
You should tell. Not I asked. You should tell before that. So it should be 0.73 angstrom units.
Yes, sir.
Good. Next question.
6.6. It is there. So.
Yeah. Anything?
Sir, 6.6 it is there, sir.
That's why 66 by 90.
66 by 90 should come now, sir.
The 10 I have taken to numerator. That's how it becomes 10 to the power of minus 11.
Yes, sir.
So 7.3 into 10 to the power of minus 11. Sorry. Yeah, 7.3 into 10 to the power of minus 11 or 0.73 into 10 to the power of minus 10. So answer is 0.73 angstrom units.
Yes, sir.
Okay. Next question. What should be the velocity of an electron? What should be the velocity of an electron so that
Yes, sir.
the momentum, its momentum becomes equal to that of its momentum,
becomes equal to that of.
a photon of wavelength
Yes, sir.
5,200 angstrom units.
Wavelength 5,200 Armstrong units. Yes, sir.
So how do you do this?
Velocity of
Wavelength of electron.
Sir, lambda momentum is P is equal, sir. P1 is equals to P2, sir. Lambda 1 by lambda 2 is equals to.
Why you need all those things? You tell me. You want V, na?
Yes, sir.
V is equal to H by M into lambda. Correct?
Yes, sir.
You want velocity of electron.
Yes, sir.
It is given that lambda of the photon is equal to lambda of electron.
Yes, sir.
Finished, over. Problem is over. So 6.6 into 10 to the power of minus 34 by 9 into 10 to the power of minus 31 into lambda. It is 5.2 into 10 to the power of minus 7.
Yes, sir.
Converted into meters. Is it right?
Sir.
Understood,
Yes,
ma?
sir. 6.6 into. Yes, sir. Understood, sir.
Yeah, this is 31 plus 7, 38. Minus
Yes,
34. So it becomes 10 to the power of 4.
Yes, sir.
These two decimals will go. So finally I will get 66 by 9 into 52 into 10 to the power of 4. So this is 7.3. 7.3 by 50. 7.3 by 50 means
7.50.
5 times 5, 1470. So 5 1.4 means 0.14. So it is
Yes, sir.
0.14 into 10 to the power of 4 meters second inverse or 1400 meters second inverse. 14,000, sorry. 1400 is correct. 1400 meters second inverse is the answer.
Yes, sir.
Yeah, you need this type of meter second inverse.
Yes.
You need this type of conversions, ma. You should be fast in simplifications. You cannot adapt a traditional way of writing the formula and then writing the ratio, then getting the formula for the quantity asked in the problem,
Yes,
then substitute, then simplify. All those things will not work out. You should be as fast as possible. Got the point?
Yes, sir.
Okay.
Yes, sir.
Then The wavelength, yesterday I told you one formula. Where I said very important formula, you have to remember I said, correct?
Yes, sir.
Now, this is a question based on that. Problem. The wavelength of a probe. The wavelength of a probe
Of a
probe, P-R-O-B-E, probe, is roughly a measure of the size of the structure, is roughly the measure of the size of the structure
the measure of size of the structure
and protons, neutrons, neutrons
Yes, sir.
appear at the minute length scale of
Appear at minute scale. Yes, sir.
length scale of
Scale of S.
10 to the power of minus 15 meters.
10 to the power of minus 15 meters. Yes, sir. It
In
yes,
an
sir.
accelerator
Accelerator. Yes, sir.
at Stanford, USA.
At Stanford. Yes, sir.
Working on quarks.
Working on quarks. Yes, sir.
What should be the order of the energy? What should be the order of the energy of the electron beams?
What is the order of energy of electrons
Given
given
the rest energy, the rest mass energy of electron.
the rest mass
Energy of electron is
energy of
electron is 0.511 million electron volts.
point
511 million electron volts.
yes, sir.
Tell me how will you do this?
Sir, E naught square is equals to E square minus C square C square, sir.
We want E na, so tell me the formula for E directly.
E is equals to P square C square plus E naught square, sir.
Correct? Huh?
Yes, sir.
Yeah, this is nothing but, of course, what you said. E naught square plus
M naught.
P square.
Yes, sir.
So you need P. E naught is there, but you don't have P.
Yes,
Yeah,
sir.
this will help you to get the value of P. How? P is equal to H by lambda. Correct?
Yes, sir. Yes, sir. Lambda is equal to H. Yes, sir.
Yeah, problem is over. Getting idea is important, man. So 6.6 in 10 to the power of minus 34 by 10 to the power of minus 15. So it should be 6.6 into 10 to the power of minus 19. Am I right?
Yes, sir.
Can you approximate it to 4 into 1.6 into 10 to the power of minus 19?
Yes,
Joules.
sir.
Joules. Sorry.
Yes,
Yeah.
sir. 4
It's
into
not
1.6, sir.
4 into 1.6 into 10 to the power of minus 19 kg meter second inverse, correct?
Yes, sir.
So now we want E.
Yes, sir.
So it should be root of
Root under E naught is 0.11
0.5 into 1.6 into 10 to the power of minus 13 million electron volts, correct? So you should convert that into joules.
Yes, sir.
Plus, yeah, 6.6 or 4 into 1.6 into 10 to the power of minus 19 whole square. This is one method, easy method of simplification. See, 0.5 into million electron volts, 10 to the power of 6 into 1.6 into 10 to the power of minus 19 whole square plus 4 into 1.6 into 10 to the power of minus 19 whole square. Correct?
Yes, sir.
This will be in joules. So what will be in electron volts? It should be root of, the whole square should be there on this also. So it should be 25 into 10 to the power of 10. Because 0.5 into 10 to the power of 5, sorry, 5 into 10 to the power of 5, the decimal is removed. So 25 into 10 to the power of 10 plus 16, so many electron volts. Simple. Correct?
Yes, sir.
So nearly it comes out to be 1.24 electron volts. Yeah, calculations won't trouble you like this, but just because we have learned a formula yesterday, I thought of making you to try one problem.
Yes, sir.
Yeah, because the formula what you have learned must be applied in doing problem, then only you'll remember. That's why I
Yes,
thought of
sir.
doing it.
Yes, sir.
Yeah. Then a few more.
Yes, sir.
How are the problems? Good.
Yes, sir.
They're little, of course, logic plus calculations in these questions based on this dual nature will be always simple. But
Yes, sir.
yeah, you need not worry much. But to just they may help you for JEE.
Yes, sir.
And NEET becomes easy if you practice them. That's all.
Yes, sir.
Yeah. Next question. If
If, yes, sir.
the energy of photon with momentum of the energy, find the energy of photon. Find the energy of photon with the momentum of, yeah, even this relation also we discussed.
Yes, sir. Energy of photon with momentum of
3.5 I said 3.5 na?
yes, sir.
Is 5 into 10 to the power of minus 12 SI units.
Yes, sir.
Yeah, find the energy. Yesterday I gave you one relation. I told you there are important relations. Even intensity relation also I gave you.
Yes, sir. I is equals P is equals to I by C. That relation, sir.
Here, of course, E by C. E is equal to P into C. So P is equal to E by C.
Yes, sir.
I will be equal to P is equal.
C, sir.
P is equal to E by C.
Yes, sir.
Yeah, if you want intensity, it is E by A into C.
Yes, sir.
Radiation pressure, if you want, it is E by A into C. All those relations I told you yesterday.
Yes, sir.
Yeah. So just substitute the values. Simple question, but getting the idea of this formula. This is need based question only. 3.5 into 10 to the power of minus 12 by 3 into 10 to the power of 8. Speed of light.
Sir, you given problem is find the energy of photon with momentum of.
Acha, you're asking to find the energy.
Yes, sir. Energy we are asking, sir. They are asking, sir.
Acha, momentum is given. Okay, fine. So direct formula E is equal to PC.
PC, sir.
Correct, na?
Yes, sir.
Yeah, good.
Into 3 into 10 to the power of 8.
Simple.
Sir.
Finished. Over.
3.5.
3 into 3.5, 10.5 into 10 to the power of minus 4.
10.5, sir.
Yeah, that's what.
10.5 into 10, 9, 10, 11, 12. 10 to the power of minus 4, sir.
9, 10, 11, 12, you are counting. Okay. So 10.5 into 10 to the power of minus 4 joules, correct?
Yes, sir.
Yeah, what is the value in electron volts?
Divided by 1.6 into 10 to the power of minus 12.
Yeah.
Minus 15, sir.
Minus
19.
10.5 into 10 to the power of minus 4 by
1.6 into 10 to the power of minus 12.
minus 19. Correct?
Yes, sir.
Yes,
sir.
So nearly 6, let us put approximation. So it is energy is 6 into 10 to the power of 15, correct?
Yes, sir.
Electron volts. Simple.
Yes, sir.
Very simple question, neat standard question.
Yes, sir.
Next.
Yes, sir.
Another simple question.
Yes, sir.
Find the momentum of photon with an energy of just same formula. Here E is asked. Next problem P is asked. Find the momentum of photon with an energy of 15 electron volts.
Yes, sir.
So it should be E by C, correct?
Yes, sir.
Means 15 into 1.6 into 10 to the power of minus 19 by 3 into 10 to the power of 8. This is 5 times 5 1.68 into 10 to the power of minus 27 kg meter second inverse.
Yes, sir.
Yeah, this is the speed you require to get.
Yes, sir.
Next. A simple concept, very simple concept.
Yes, sir.
A radio transmitter
Yes, sir.
operates at a frequency of 1000 kilohertz
Yes, sir.
and a power of 66.2 kilowatts.
Yes, sir.
How many number of photons per second are released? How many number of photons per second are released?
Yes, sir.
Yeah, tell me how you do this.
Power given, sir. Power is equals to energy by time, sir.
Good, very good, excellent. So whatever you are telling, I am putting the step. Power is equal to energy by time. Yes.
Sir, and here frequency given, sir.
Okay.
Power is equals to energy by time means. Energy is equals to P by C, sir. E is equals to PC, sir.
P is power here, not momentum.
No, sir. Again, energy is equal to momentum into speed of light, sir.
Yeah, where is the momentum?
Momentum.
From where you will bring momentum here? It's not given.
Sir, another one formula in NCERT given N is equals to P by E or something.
I will tell you. Look here.
P
Let us
is
suppose.
only one formula is there, no, sir?
Here. I am telling you. This is a power, na? You
Yes,
are right. Energy by time. Correct?
Yes, sir.
It is emitting n photons in what time?
Seconds,
1 second.
sir.
1 second.
1 second.
Energy
Yes.
of each photon, you take it as E naught.
Yes, sir.
How many photons are released?
N number of photons, sir.
In how much time?
1 second, sir.
So it should be n by t into E naught, correct?
Yes, sir.
Then it should be n by t into what is E naught?
H nu.
Yes, this is the formula for power in terms of number of photons per second. Suppose sometimes you'll be given wavelength. Then the formula for power is n by t. You write clearly power. So there won't be any problem, confusion with momentum or pressure. All have same symbol. That's the issue.
Yes, sir.
So power P is equal to n by t into h nu. That is n by t. Suppose if you are given wavelength, hc by lambda. Correct?
Yes, sir.
Now you got the answer. Finish. What do you want here? Simple question. You want number of photons
Yes,
per
sir.
second. So
Power.
n by t will be P by h nu. Correct?
Yes, sir.
You're saying I am writing here. Could you see the formula? I put it box.
Yes, sir. Yes, sir. Yes, sir.
Okay. So what is the power here? 6.2 kilowatts is given. So it should be converted into watts. Into 10 to the power of 3.
Yes,
Correct?
sir. Yes, sir.
Then 6.6 into 10 to the power of minus 34. Planck's constant.
Yes, sir.
1000 kilohertz. 1000 into 10 to the power of 3. 10 to the power of 6.
Yes, sir.
So minus 34 plus 6. Minus 28. Plus 28 means 10 to the power of 31.
Yes, sir.
This is nearly 10. So
Yes, sir.
10 to the power of 32 photons are released in every 1 second.
Yes, sir.
Got it?
Yes, sir.
10 to the power of 32 photons are released in every 1 second.
Yes, sir.
See how easy the problem was.
Yes,
So
sir.
have clarity. P, momentum is there. P, pressure formula also I gave you yesterday. Yes or no?
Yes, sir.
What I am referring in this
Yes,
problem
sir.
is, what I am referring here is power. Okay?
Yes, sir.
Okay. Take the next question. Simple. You can do it.
Yes, sir.
The ratio of wavelengths of protons. Find the ratio of. Find the ratio of
Yes, sir.
wavelengths of
Ratio of wavelengths of yes, sir.
proton and deuteron.
Wavelength of proton and neutron. Yes, sir.
When accelerated by the potentials.
When accelerated
By the potentials.
by the potentials
In the ratio.
in the ratio
√2:1.
yes, sir.
So how to do this? Lambda is equal to, I gave you a formula yesterday, h by root of 2m into q into v, correct?
Yes, sir.
Proton and neutron, they have, you should identify the constants first. Proton and neutron have got same charge, correct?
Yes, sir.
2 is a number, h is Planck's constant, they are the constants.
Yes, sir.
Therefore, you want the ratio of proton to neutron. So, say lambda 1 is to lambda 2. So, this should be root of m2 by m1 into v2 by v1. Am I right?
Yes, sir.
Now, the speed what you need to get is, whenever you read this type of problem, the formula should flash in your mind. Substitution should come in the space for rough work.
Yes, sir.
So how will we get this? Today we are doing some say 8 or 9 problems. You
Yes,
just
sir.
interchange the parameters. Each model what you did today, at least 3 problems you have to practice on each model what you did today.
Yes, sir.
So 9 into 3, 27 to 30 problems you must practice today based on the relations what we have done today and yesterday.
Yes, sir.
Then any question from dual nature, blindly you can answer correctly. Okay.
Yes, sir.
So
Yes, sir.
mass of neutron, how much? 2 mH.
Yes, sir.
Mass of proton, mH.
Yes, sir.
Yeah, what are the ratio of voltages? It is root 2 is to 1, correct?
Yes, sir.
So it is 1 by root 2.
Yes, sir.
Therefore, you will get root of root 2.
Yes, sir.
Yeah, this is not.
Find the ratio of wavelength of proton.
Yeah. So how much? Lambda proton to lambda neutron is 2 to the power of 1 by 4 is to 1. Correct? Huh?
Yes, yes, sir.
2 to the power of 1 by 4, can you tell me the value?
Sir? No, sir.
2 to the power of 1 by 4 value.
Root.
It should be 1 point, nearly 1.2, Ray. How I could tell? Root 2 1.414. Correct? Huh? Root 2 1.414. Root of 1.414 is 1.2. 12 12s are 144.
Yes, sir.
So nearly 1.2. Nearly.
Yes, sir.
You should get the logic behind calculations when you are when I'm doing another sheet, right?
Yes, sir.
Yeah, one more.
Yes, sir.
Find the potential to be applied.
Find the potential.
Find the potential difference to be applied.
To be applied.
To accelerate the electron.
Applied to accelerate the electron.
So that.
So that is.
It's de Broglie wavelength.
It's de Broglie wavelength. It's
becomes 0.5 angstrom units.
Becomes 0.5 Armstrong units. Yes, sir.
That's all. So same formula.
Lambda is equals to h by root over 2mq into potential difference. Sir.
That's all. So you want to V.
Yes, sir.
Therefore, h square by 2m into lambda into E. Correct?
Yes, sir.
So it is 6.6 whole square into 10 to the power of minus 34. Whole square means
Sir,
10 to
your
the power
lambda
of,
also will get square only, sir.
yeah, good, very good, right? Lambda also will be square. Yes. So 6.6 whole square into 10 to the power of minus 68 because minus 34 whole square, correct?
Yes, sir.
2 into m into 9 into 10 to the power of minus 31 lambda square
Yes, sir.
25 into 10 to the power of minus 22.
Yes, sir.
How I got 5 into 10 to the 0.5 into 10 to the power of minus 10 meters
Yes, sir.
means 5 into 10 to the power of minus 11 meters.
Yes, sir. 5 5 sir, 25.
So lambda square 25 into 10 to the power of minus 11 whole square 10 to the power of minus 22 multiplied by 1.6 into 10 to the power of minus 19.
Yes, sir.
So minus 31 minus 19, 50. 50 minus 22 minus 72. So 10 to the power of 4.
Yes, sir.
Then what more are left? 6.6 into 6.6, you take out 100 by 18 into 25 multiplied by 10 square because out of 10 to the power of 4 I have taken 100. So 25 fours. This is nearly 2s. So 800 volts. I am approximating. So the required answer is 800 volts. You do it accurately. Don't follow my approximation techniques, right?
Yes, sir.
Sir is doing so, I will also do. Don't do that.
Yes, sir.
You do accurate calculation and let me know tomorrow.
Yes, sir.
Yeah, tomorrow we'll do few more problems and start photoelectric effect.
Yes,
The
sir.
second part of dual nature, right?
Yes, sir.
Yeah, ask me what's your doubt.
Sir, you told to do some problems with errorless book now, sir.
Correct, correct.
Sir, but there are more number of 500 problems per chapter. It is
Yeah,
there.
that's what. You select around 40, 50 problems, that's all.
How to select accurately which problems?
How I am selecting problems to give you, you are not finding a similar model, same model of problem from one to another when I am switching over, correct or not?
Yes, sir.
So you should select problems of that type, which are not repetitive.
Yes,
Repetitive models are not to be selected.
yes, sir.
So I have given you a scope of 5 or 6 relationships in dual nature.
Yes, sir.
So what you need to do is pick out questions based on all these 5 or 6 standard relationships what you have practiced.
Yes, sir. But first, for that, if we read all questions only, we will know which is that
You
model.
you make a fast reference there. Don't get stuck there.
Yes, sir.
Because I don't have errorless book right now with me. Otherwise, I would have given you selected the questions for
Yes,
you.
sir.
So you just finish that work for every topic, sparing half an hour or 40 minutes. Dual nature you are doing it. See,
Yes,
list
sir.
all the formulae, 6 or 7 relations I gave you yesterday.
Yes, sir.
First relation, 5 questions. Second relation, 5 questions. Third relation, 5. Fourth, 5. Fifth, 5. Sixth, 5. 30 questions. Finish.
Yes, sir.
You see the solutions if necessary for selecting the questions, not for copying the solution.
Yes, sir.
Yeah, I think you got the point.
Yes, sir.
Yeah, see the solution.
Yes,
Keep the list of the formulae that come in this dual nature.
yes, sir.
For each formula model, you select 5 questions.
Yes, sir.
So all these relations what we discussed yesterday and day 4 should be covered in the problems which are selected by you.
Yes, sir.
Each model, each formula, 5 problems.
Yes, sir.
Yeah, practice those 30, 40 questions. Close the topic. Don't think of it again.
Yes, sir.
Yeah, this you can revise before your exams.
Yes, sir.
That is the best method.
Yes, sir.
Okay?
Yes, sir.
Yeah, take care. Work hard.
Yes, sir.
All the
Yes, sir.
best. Okay, ma'am.
Yes, sir. Thank you.
Yeah.
Yes, sir. Thank you, sir.
Okay, okay.
Yes, thank you, sir.